Welcome back as we conclude this program by demonstrating the procedure for performing a full load test, sometimes called the stall test. It must be well understood that in order to guarantee accurate results from this test, the battery being used must be in perfect order and be fully charged. Any starter motor that has been fully overhauled should ideally be bench tested to ensure that it meets requirements on the vehicle. As previously demonstrated, the starter is set up onto the test bench and the necessary electrical connections made. A no-load test is initially performed simply to ensure that the unit operates normally. After a short rest period, the starter is run and the load control is quickly turned to apply load to the flywheel. As the load increases, the voltage will tend to drop and the amperage will increase. The test is made by increasing the load until the motor stalls, and then the amperage and the voltage are noted. The starter is released and the power isolated as quickly as possible. The test must be done as quickly as possible, within 15 seconds, to avoid thermal overloading of the motor. Every starter type, make and model will have its own specification as to the amperage draw at stall, but even the smaller types will be in excess of 100 amps. Only by comparing the results of this test with the manufacturer's specification will you be able to determine whether the motor is normal. An amperage draw higher than specified means that the starter motor will need to be repaired or replaced with a new unit. When the tests have been concluded, all controls on the test bench should be set to the off and no load position, and the battery recharged ready for the next situation. This brings us to the end of this program. Practice the test procedures detailed using your Amron AE 750 tester or the one available in your training workshop. You can learn more about auto-electrical test and repair procedures by viewing other Tech AV programs.